Hello, Algebra 1 students. Guess who's back? It's Mr. Blum. I know you're so happy. I'm going to apologize right away because this is a new video format and a new software because nothing works and it is the worst. Anyway, we're in a new booklet. I apologize right away for the long video, but I'm going to do my best to go quick through it. There's a lot of material. It's very, very, very important. This is the most important booklet and unit in the entire of Algebra 1. So first, make sure you put your name on it. I'll put my name real quick. Maybe. Oh, there it goes. By the end of this lesson, you should be able to solve one-step equations. Okay? So they'll go pretty quick. There's a ton of examples. So, we think of one-step equations as a balance with the equal sign being in the middle. We want both sides to be the same. However, we don't know what's in these variable mystery boxes. Could be 1, 2, 3, we just don't know. So we have to treat it like we don't know. Numbers are easier to think about on the balance. So when we solve equations, we must do the same thing to both sides. I also can't write small in this new software, it sucks. So we're going to solve x plus 4 equals 6. I'm going to use the balance to help us understand what's going on. So on our balance, you got an x, and you've got 1, 2, 3, 4, just like we have x plus 4. And then on the right side, we have 6. Now you could probably really easily solve this right away, but I warn you, you're not going to be as well off if you don't listen. So when we think of a balance and we want to keep it simple, we want to keep it balanced, we take one of these off. If we take one of those blocks off that side, well, that's going to make this second side heavier. So I'm going to need to take one off this side to keep it balanced. So we would take off one from each side of this equal sign. So we could do x plus 4 minus 1, which is x plus 3 now, which we can see in our picture, equals 5. Now we could take off one at a time. That would be kind of slow. But I'm going to take off 1, 2, 3 from this side. Bad color choice. There we go. So minus 3 from that side of the equal sign. And if I take off 3 from the left, I have to take off 1, 2, 3 from the right, because that will keep my scale balanced. So now we just have x equals 2, because there's 2 blocks left over. So your booklet lays that out a lot nicer. I'm sorry for mine. But we should get this 2, x equals 2, where you end up at the bottom. So moving on. There is a huge warning. Warning. It is so easy to see that the answer is 2 before you even started. However, you need the ideas and techniques to solve the equations. I know I just read to you. If you don't know how to solve it, you will be in huge trouble this school year. You can ask all the people who are taking Algebra 1 with me again how important it is. So, can you solve this in your head? I can't solve that in my head. There's a fraction in there. Maybe I could because I'm pretty good with fractions. But anyway, you need the techniques. So I'm going to show you a table that helps us organize the algebra. So this is what operation we are doing to the variable. In this case, our variable is x. And we go in order of operations. So by the order of operations, we are adding 3/5 to x. So then we want to know what are the opposite operations. So the opposite of adding is subtracting. So we would subtract 3/5 to undo that. So we're going to use that right now. So we're going to subtract 3/5 from this side, and we're going to subtract 3/5 from this side. So we now have 3/5 minus 3/5, which is 0, so that is gone. Now we have x equals 2 minus 3/5, which, as you all know, is 7/5. Now, could you do that in your head? I doubt it, but again, it gets so much more complicated. You need to know how to do it and how it works. So in example 2, we need to figure out what's going on. So we need to start by adding any understood operations that may not be shown. So this is actually 3 times x. If I could get that to work with my pen, probably not. There we go. I guess 3 times x. It's not big. So we're doing our order of operations to our variable x. So what were we doing to x? Well, we're multiplying by 3. So how do we undo that? We divide by 3. So I'm going to divide both sides by 3. Whatever I do to one side, I have to do to the other to keep it balanced. 3 divided by 3 is just 1, so we have 1x. And 21 divided by 3 is 7. So there's my answer. I could check it by plugging 7 back in for x, and I would find out that it works. Then, we're going to keep going. So now we're going to read it. So any understood or invisible operations, there's none in this one. We're doing our order of operations to m this time. So what are we doing to m? Well, we're subtracting 9 from m. So to undo that, we need to add 9 to m on both sides of my equation. So if I add 9 over here, to keep my equation balanced, I have to add 9 over here. So I get m, and this is negative 9 plus 9, gone, don't worry about it, and negative 13 plus 9, that's negative 4. Done. Okay, negative 4 if you can't read that. Same thing, if you could get this, pause it, try it on your own, and then check the answer when we go back. But I'm going to keep going. Are there any understood invisible operations? Not in this one. And now we read it. We're doing our order of operations to b, which is our variable this time. And what we're doing to b is dividing by 9. And so we undo that division by 9 with multiplication by 9. So on both sides of my equal sign, I'm going to multiply by 9, maybe. Times 9 times 9. Well, dividing by 9 and multiplying by 9 cancels, so we now have our b by ourselves. And negative 6 times 9 is negative 54. If you want to use your calculator, go for it. I don't care. And next, we need any understood or invisible operations. In this case, we do. We have negative 11 times k. So if we did our order of operations, PEMDAS to k, which is our variable this time, we are doing times negative 11 times k. So how do we undo that times negative 11? Well, we divide by negative 11. So on both sides. So if we divide this side by negative 11 and divide this side by negative 11, well, what that gives us is negative 143 divided by 11. I think that's 13. Over here, we got negative 11 divided by negative 11. That's just gone. So we have k. K equals 13. So that was a bunch of examples that were easy. We need one more new thing. We need the commutative property. The commutative property, when adding or subtracting the order, does not matter if you keep the sign in front of the number or variable. Ugh, this app is terrible. So we want to use this property for the next examples. So we need to keep the sign in front. What's the sign in front of 8? Well, that's positive. It's a positive 8. We don't really need to write a positive because we already know it's positive. But we want to figure out what we're doing to v. Well, the order's backwards, but by the commutative property, I could rewrite this equation as 26 equals v plus 8. The order doesn't matter as long as you keep that sign in front of the number. So the sign in front of v is plus, which you don't need right now. The sign in front of 8 is also plus, so we kept it. Now we'll read it and do it. So what are we doing to v? Well, we're adding 8. How do we undo that? We subtract 8. Those are the opposites. So now I'm going to subtract 8. From this side, if I do it to one side of the equal sign, I also have to do it to the other one. So, on my left side, 26 minus 8, that is 18, if I did my math correctly. We still have v, and then we've got 8 minus 8, which is just 0. So we have v equals 18. Next, same thing. We can change that order to help us read it a little bit, but we need to keep the sign in front. The sign in front of negative 7 is minus. That's the sign in front. The sign in front of m is plus. We can change the order, but we need to keep the sign. So now we have plus m minus 7 equals 8. Okay, so we're doing our order of operations, PEMDAS to m, and what we're doing to m is we're subtracting 7. We undo that subtracting 7 by adding 7. So, in my little chart, let's use some purple. I'm going to add 7 to the left side. If I add 7 to the left side of the equal sign, I have to add 7 to the right side. Whatever I do to one side, I have to do to both. So I get m, we have negative 7 plus 7 over here, that cancels, equals 8 plus 7, which is 15. All done. Please check your answers when you can. Put this 15 back in for m and check it. Number 8, I believe, is our last example. So same thing. We're going to switch the order so that we can see what we're doing to n. So this time we're going to have n minus 15 equals negative 9. That negative 15 is over here on the right now. You can see that very clearly. But I switched the order. The sign in front stayed the same. So you can read what's going on. So what's happening is we're doing order of operations to n while we're subtracting 15 from n. So we undo that by adding 15, and we're going to do that to both sides. So we add 15 over here, we add 15 over here on both sides of the equal sign. That's where I draw my line every time. So I get n, and negative 15 plus 15 is gone, equals, negative 9 plus 15, which is 6. All done. So, please re-watch. Maybe. Any confusing part? Any part that you think you need more help on? Ask questions from our teachers. If you don't understand what I just said, I can explain it in a different way. And your teachers, if you're not in my class, can also explain it in a different way. And then you need to complete your tiered assignments. So complete your tiered assignments, and again, ask questions. Please ask each other. And then in my class, put your cups on red if it's not working. We can explain it, and this is so important. You have to ask questions and understand this. If you don't, you will not do well in this class at all. I swear, it's the most important thing, and it just gets harder from day one. So please ask questions. Sorry for the long video. It wasn't too long. You'll survive. And see you in class. Happy whatever. Bye.